On my video about using the data transfer to smooth out potential visual issues with surface shading, I had a couple of comments suggesting that I could potentially have done it better by using the Shrinkwrap modifier to make sure that the geometry was correct and to not use a shading trick. That was sort of the essence of the comments, and I want to show you why that's not exactly true, but I'm also going to show you why it is that using Shrinkwrap could potentially also help you in some ways. I also just want to point out that using data transfer to pull normals from the more pristine pull normals from me mesh is actually how NURBS modelers generate normals for the polygon mesh data that they derive and that you export and bring into general purpose 3D applications like Blender. NURBS applications are defined by these mathematically perfect surfaces, and in order to display them, they have to be broken down into polygon structures. And those polygon structures are going to have varying degrees of resolution based on how you want to tessellate them. And especially the lower the tessellation rate, the more crude the polygon mesh is going to be. But these meshes still often look really good because the application, any NURB application you're using, is pulling and calculating normal information based on the actual NURBS data, not on interpolating vertex normals from the resulting mesh. So essentially this quote-unquote trick that I've showed you is essentially what NURBS applications do to generate normals for the polygon meshes they generate. So let's come in and turn off the data transfer that we have for both objects. I have these as two separate objects. The little detail, the design element as I called it, we could have integrated those. It's just the way I happen to choose to go. So turning off data transfer, we see sort of the wonkiness reappear. So the question is, can we actually take the geometry and improve the geometry by using a Shrinkwrap modifier? And the answer is kind of. It's still not going to be as good, and I want to demonstrate why. So if we come over, let's come back to subdivision surface and we turn off optimal display, we can see the actual polygons that are being generated by the subdivision surface object. And we can, in fact, use a Shrinkwrap modifier to flatten them or shrink wrap them directly to this object that I called pull normals from me. Okay, so let's go ahead and do that. So let's come back over and let's add a modifier of deform, and we're going to come down to shrink wrap. Okay, there we go. It needs to be underneath subdivision surface because we're working on the subdivided geometry. Applying this on top of the cage wouldn't really yield anything. So we need to restrict it to the blend verts. We want to restrict it to the same geometry that we were restricting data transfer to. And then we'll come over and pull normals. So you could see that there was a shift right there. Okay, so let's come over. Let me just make sure that that's very clear. Let me turn off shrink wrap and then turn it back on. And you can definitely see that that was operating. Now we do need to make a bit of a change here, because if we come in, we also need to make sure that this bevel geometry right there, that this also gets applied. So we need to come down here and assign it, whereas we didn't with the data transfer method when we were just transferring normals. So that is important. Okay, now let's come over and take a look at this. Let's just come back over, and it's a little bit better. It's a little bit better, but when you look here, we can still see that there are some shading issues. And you can see there, I know it's going to be a little bit hard to see, but there are still some issues there. So let's come over and do the same thing to this object. So we're going to come over, data transfer is turned off. We're going to add deform shrink wrap. But in this particular case, I'm actually going to apply shrink wrap to the cage, because if we come into edit mode, I had added enough geometry that I think just applying it here to the cage would probably be good. But we also need to modify the blend vertex group. That needs to be assigned also. Okay, so let's come in now. Let's come back to our modifier. back up to Shrinkwrap, and we're going to restrict it to the blend vertex group. And then we pick this pull normals from me for it to apply. And you could see that in fact it took that. So I think that would actually be good, because that actually takes and moves that geometry, so we don't have just the kink over here on this third sort of section of the geometry. So again, if I turn this off, and then if I turn it back on, I think that works pretty well. So is applying shrink wrap to get the geometry more accurate the best method? And the answer is no, it's not, because you can still see that there are some glitchiness because the normals are still being calculated by all these triangles in there. Let's come in and take a look at this, and it's very clear that just using shrink wrap isn't sufficient. So this is where you could use a combination of both. I mean, if you really needed that geometry to be accurate, and I think there's a case to be made for this design element for doing that. I don't think there is for the major portion of the geometry we're working on. But then you're just adding two modifiers, and one of the criticisms was, well, hey, this is just too difficult, to do with all these modifier stacks. And I don't think that's the case. Setting these up is actually really quite easy once you've done it a couple of times. So anyway, I just wanted to show you this, why just using shrink wrap isn't necessarily the best way to do it, but you could definitely mix and match the two. So you can see here on the left, we're using the shrink wrap method, and there's still some crinkliness to the surface. It still is a little bit not quite right, whereas with the data transfer method, it's basically perfect. So anyway, I hope you found this to be useful.